Good morning, students. Let us start with last fifth part of your chapter 5, States of Matter. We are now trying some new concepts here. First of all, we will deal with cubic equation in volume. Van der Waals equation you have studied earlier in the last slides of few parts. It is P plus AV square into V minus B is equal to RT. The arrangement of the equation in volume term is a cubic equation in volume. It becomes now V cube minus B plus RTP whole V square plus APV minus ABP is 0. The cubic equation gives three volumes that are useful for calculating the volume at and below critical temperatures. Now, what is critical isotherm? The plot between pressure and volume at constant temperature is called isotherm. We can plot isotherm at various temperatures for the real gases. At high temperature, the pressure volume curve shows some characteristics as ideal gas. At certain temperature, we formed a small region where the curve is essentially horizontal with no curvature. At this point, there is no change in pressure as the volume changes, and this is called critical. Let us try to solve one question, and this numerical is already solved on the screen. A 39 decimeter cube cylinder contains 210 gram oxygen gas at 21 degrees Celsius. What mass of oxygen will be released to reduce the pressure in the cylinder to 1.24 bar, and value of gas constant is given. Its solution is on the screen. You can easily sort out this. Here, formula of ideal gas PV is equal to nRT will be applied. For this, you have to first convert temperature into Kelvin, and N number of moles is given 1.7 mole. So you have to calculate first mole. Mole is mass upon molar mass, means weight upon molar mass, and weight you have to calculate, and weight of air released will come out to be total mass, that is 212 gram of oxygen minus mass, so calculated by you. The answer will be 157.6 grams. Now start with liquefaction of gases. Low temperature and high pressure are the fact condition for liquefaction of gases. The reason is at high pressure and low temperature, intermolecular forces start operating strongly between the molecules of gases because they come close to each other. Under suitable temperature and pressure, conditions of gases is that they can be liquefied. Number 1, what is critical temperature? In fact, these three definitions, critical temperature, critical pressure, critical volume, they are very important definitions. So, it is defined as the temperature above which a gas cannot be liquefied. However, high pressure may be applied on the gas, and its formula is quite visible on screen. Tc is equal to Tc. T means temperature, C means critical. So, Tc is critical temperature. Tc is equal to 8a square 7b square, and a and b you know very well. These are the parameters used in Van der Waals equation. Now, critical pressure. It is the pressure required to liquefy the gas at critical temperature. Pc means critical pressure. A square 7b square. Now, critical volume Vc. The volume occupied by 1 mole of gas at critical temperature and critical. Now, here are again few questions. These questions are solved. Just try to solve these questions and write down on your note. Now, let's come to the third state of matter, liquid state. This is the last topic of the chapter. Liquids may be considered as continuation of gas phase into a region of small volume and very strong molecular attractions. Molecules of liquid do not separate from each other, but molecules of liquids can move past one another freely. Therefore, liquids can flow, can be poured, and can assume the shape of the container in which these are stored. It is very well known to all of you. These are properties of liquid state. Now, vapor pressure. The equilibrium pressure by vapor of liquid in a container at given temperature T. Now, what is boiling point? When the liquid is heated in the open container, its vapor pressure starts increasing. When vapor pressure reaches atmospheric pressure, then vaporization occurs in the bulk of liquid and vapors freely moves in the surroundings. This temperature is called boiling point. At 1 atmosphere pressure, boiling temperature is called normal boiling point. If pressure is 1 bar, then the boiling point is called standard boiling point of the liquid. At higher altitude, the boiling point of water decreases because the atmospheric pressure is less than 1 atmosphere. Now, what is surface tension? It is force acting per unit length perpendicular to the line drawn on the surface. It decreases with increasing temperature. It increases with increasing external pressure. Because of it, falling drops of liquid are spherical. Liquid in capillary tube rises. It has dimensions of kilogram per second square and its SI unit is Newton per meter. Now, the last term, viscosity. It is resistance offered to the flow of liquid due to friction between layer of fluids, and force of friction is eta into A du by dv. Now, eta is viscosity coefficient and A is area of cross section and du by dv is velocity gradient. Viscosity decreases with increase in temperature and increases with increase in pressure. So, your chapter completes here. At the end of chapter, as usual, you are always provided a series of questions in term of assignments and in term of question bank. So, complete the chapter on your notebook also and prepare the chapter with back exercise and in-text questions also. So, thank you so much.